Following the accidents at Chernobyl and later Fukushima, the public perception of nuclear power has significantly been injured. According to the most recent Gallup poll in 2019, which asked overall, do you strongly favor, somewhat oppose, or strongly oppose the use of nuclear energy as one of the ways to provide electricity for the U.S., the American public was evenly split, with 49% in favor and 49% in opposition. Although the American people are split on the issue of nuclear power, the United States has the most operational nuclear reactors on the planet, 96, making up 20% of the country's electricity generation.
Your official quote unquote title is.
Yeah. I'm a nuclear electronics technician for the Navy, reactor operator. I control the primary plant, which is where the reactor is. So, the core generates heat from fission, and then that heat is transferred to a steam generator, which generates steam in the secondary, and that goes and spins a turbine. So I control the nuclear stuff.
So what kind of safety protocols do you have to follow?
A ton. Quite literally, the motto of the nuclear Navy is procedure. Everything that you do is written down. You always have the supervisor, always. We do a ton of inspections. And on top of all these procedures, the reactor itself is inherently safe. That's what they call it. It's called a negative temperature coefficient of reactivity. I guess the best way to explain it is you have the concept of reactivity. The output of your reactor effectively is contingent on how much reactivity you have in your core. So with a negative temperature coefficient of reactivity, if you have an increase in temperature, it's negative, right? So it's going to decrease, right? Your reactivity overall, your change in reactivity, which is the fractional change in neutron per population per generation, it's going to change it's going to trend to the opposite direction of your temperature. So if you look at it on a graph, it's kind of like a slingshot, and that makes it inherently safe. You won't have a meltdown because the temperature literally is inversely proportional to the reactivity, which means, you hear about Knoll and stuff. Their thing was they used a different moderator, and their moderator had a positive temperature coefficient reactivity, which is bad. Not necessarily bad, but it's not inherently stable. It's not super, super safe like naval reactors, and it's all contingent on design and a whole bunch of engineering stuff. But I think the fact that we can stick one of these on a submarine with 150 people, and the nuclear Navy has never had an accident, not in its entire existence. I think that's a testament to how safe the reactor design is.
Mm-hmm. What does the process of handling waste look like, and to what degree can you reuse waste as fuel?
Yeah, you can recycle your fuel, like the depleted fuel, but that's not the problem that most people are concerned about. It's the ionizing radiation, the activated coolant, and everything else, because that you can't really dispose of the other stuff. They just kind of take it to a place and bury it. But I guess I have faith in engineering will figure something out. Whether that's launching into space or, I don't know, but we'll do something. But it is a problem, 100%. It doesn't just go away. We don't really have a way to get rid of it. It's just where your priorities lie, right? So if your concern is climate change or CO2 output, the ionizing radiation, it's a different problem that will have different consequences. So I guess you can look at it as which is more imperative, which do we need to figure out sooner, right? And I think we know which one that is. I don't know. I think it has a place in our future, but I hope it does. The best case scenario is someone figures out fusion, and then we literally don't have to worry about anything.
Okay, wait. So since you brought it up, what is the difference between fusion and fission?
Fission is the splitting of an atom. Fusion is the combination of an atom, super simple, Google terms. But the effects of that are pretty significant, because if you're decaying from like a super, super heavy atom with a super big nucleus, you're going to have a fission product that's going to release ionizing radiation of super long half-life, and that's going to be bad news. But if you're operating a fission reactor, which unfortunately we can't yet, trying to figure that one out. Smart people and their protractors and sketchers are working on that one. But it's the combination of two hydrogen atoms, and all you get is helium. You can make some pretty dope balloons, but there's no CO2, there's no fission products or any ionizing radiation, just a ton of energy. And, I mean, of course, it's a huge engineering problem because the energy output is just nuts. We don't even know how to contain it. But if some smart guy can figure that one out, it's a huge step up for everybody, for everything, really.
And so basically, the promise of that would be higher energy output and solve the waste problem.
Yes, at least to my understanding.
In a recent report from the U.S. Department of Energy pursuant to an executive order from Biden, it was identified that nuclear power should be a key component of the U.S.'s energy transition. They suggested enabling private sector partnerships with national nuclear labs, funding critical gaps in nuclear R&D infrastructure, and supporting the deployment of advanced nuclear reactors in a timely manner. The best way for the Biden administration to fortify the U.S. energy sector, decrease American oil dependence on pariah states, and reach its goal of net zero by 2050 would be to drastically increase the funding of and support behind nuclear power and other alternative sources of energy.